here, I know I think if I remember correctly, we might have started this last time, but I just want to start from the beginning though, mostly because that's what I did in the other class as well. So in this section, which is 2.2, if I remember correctly, although that might be the 3rd edition, not the 4th edition of our book. But anyway, in this section, what we're going to do is we're going to look at graphs of equations in 2 variables. You know, before we dealt with equations, right, in one variable, namely in one variable x. Here, though, what we're going to do is kick it up a notch and consider equations in 2 variables now. That's what we're going to do, okay? We're going to see 2 variables now. In particular, we're going to see graphs of certain equations. For instance, we're going to see the parabola, and we're going to see the circle. I mean, the circle actually is very useful, especially if you go on to pre-calculus and you consider trig functions, more general trig functions, more general than what we do in this class. All right. So that's what we're going to do in this section. All right. Okay, so what exactly is a graph, though? Well, you probably have seen graphs or even made some in high school. Sorry, I had to blow my nose. So you probably have made some graphs and seen them in high school. But what exactly is a graph, though? A graph is really just a collection of plotted points in the Cartesian plane. You know, it's just a collection of points that have been plotted in the plane. That's really all a graph is. So for instance here, if I just plotted this point, 1, 3, we do have a graph there. I mean, it may not be a graph you would analyze for hours or something like that, but it is still a graph technically. It is a graph, okay? You know, just any collection of points plotted in the plane, in the Cartesian plane that is, also called the XY plane, is a graph. So that's what a graph is by definition. And here's some more terminology. Remember how we considered solutions to equations, right? They were just numbers you can plug in for the variable x and such that the equation was true, right? Equations could be true or false. Well, in 2 variables, we're going to kick it up a notch because now we have 2 variables floating around. Well, in this case, solutions are not going to be just numbers. They're going to be ordered pairs. They're going to be ordered pairs of numbers. Namely, a solution in an equation, in 2 variables, x and y. It's an ordered pair, okay, A, B. So that when you replace x by A and y by B, the equation is a true statement. So you're not plugging in just numbers now. You're plugging in ordered pairs of numbers. You know, the first one is the x coordinate, right? That goes in for x. The second number is the y coordinate. That goes in for y. And when you do that, it's a solution if you get a true statement, right? Equations, remember, can be true or false. Okay. Now, as an example of this, let's suppose we have this equation, y equals 2 times x minus 1. Okay, well, is 2, 3 a solution to that? Well, if I replace x by 2 and y by 3 in this equation, right, what I get is 3 equals 2 times 2 minus 1. I get 3 equals 2 times 2 minus 1. So because, and this is actually a true statement, right? You get 3 equals 4 minus 1, which is 3. That's a true statement. Hence, the right-hand side is equal to the left-hand side. So we get a true statement. So this is a solution to the equation. For 1, 3, okay, here, this is not going to be a solution. Now, how do I know that? Well, if I replace x by 1 and y by 3 in this equation, right, I'm going to get 3 equals 2 times 1 minus 1. This is what I'm going to get here. 3 equals 2 times 1 minus 1. That's a false statement, though, right? Because this is saying 3 is equal, this is saying 3 is equal to 1, which is not true. So this is not a true statement. Hence, this is not a solution. Likewise, for the origin here, 0, 0, this is also not a solution, right? Because again, if I replace x by 0 and y by 0, okay, I'm going to get 0 equals 0 minus 1. And that's saying 0 equals negative 1. Well, that's false also. That's not true, right? So the right-hand side does not equal the left-hand side, hence it's not a solution. Now, we can actually obtain many solutions to this equation. Namely, what we can do is let the x vary and calculate the corresponding y. You know, if I let x be 1, by direct calculation, y would have to be 2 times 1 minus 1, which is 1. If I let x be 0, we would get y would have to equal negative 1. In other words, we can let x vary, okay, and calculate corresponding y's, and that will give us many solutions to this equation. That's what I'm saying here. And then, if you were to plot all the solutions to an equation like this in 2 variables, you would get the graph of the equation. So the plot of all solutions, okay, to an equation in 2 variables, that is called the graph of the equation. So when they're saying sketch the graph of an equation, what you're actually doing is you're plotting all the solutions to it. Now, how do you actually do that, though? Well, you might know already how to graph this, but let's assume we don't. What I did was I just chose some x values, negative 1, 0, and 1. I chose these kind of randomly. You can really choose any x values you want so that when you plug it in, the answer you calculate makes sense. So we could choose any x values we want. Then we calculate the corresponding y values, right? That's what I'm doing here. This is also what I meant by if you let x vary, then you can calculate the corresponding y value and get a solution. This is what I meant by that. So when x is negative 1, we get the corresponding y value, right? And what we get is negative 1 comma negative 3. That's what we get. From here, what do we get? X is 0. Right? Again, that's just a number I'm choosing. We calculate y. We plug it in. We calculate y. We get negative 1. We get 0, negative 1. And so on. When x is 1, we calculate y, right? So we get 3 solutions here. And then we can plot them to get the graph of this. I mean, once you plot these, you would connect them, kind of like connecting the dots. I mean, the graph I actually made here already. I actually sketched this using GeoGebra. But the idea is the same. You would get some solutions, right? That is, you would choose some x values, okay? Calculate the y's. Then you form the corresponding ordered pairs, plot them, connect them. And that gives you an approximation, I should say, to the graph. Because you only have 3 points, though. But the more points you have, though, of course, the more accurate your graph's going to look like. In this case, the graph of y equals 2x minus 1, right? If you were to plot these 3 points and then connect them, you would get a straight line, like so. Okay? You would actually end up getting a straight line. I mean, 1, 1 is here, 0, -1. -1, when x is -1, that's really down here, you can't see it, but still the idea is the same.